Around 1.5 trillion bricks are produced every year around the world. Few people realize that every single one of them begins as soft clay that seems almost worthless. After going through a series of manufacturing steps and being fired at extremely high temperatures, this easily shaped material is transformed into one of the strongest and most durable building materials ever used by humans, helping create structures that can last for centuries. So, what exactly turns soft clay into such hard, solid bricks? Let's take a closer look at the complete brick manufacturing process inside a modern factory. The history of bricks began when people discovered that clay could be shaped and hardened by heat. The earliest bricks were simply dried under the sun, and first appeared around 7000 BC in ancient Mesopotamia. However, these sun-dried bricks were fairly fragile and could be easily damaged by water. The major breakthrough came when people learned how to fire bricks in kilns, producing bricks that were much stronger, more durable, and able to withstand harsh weather. From then on, bricks became one of the most important building materials used by civilizations such as Egypt, Rome, and China. Although the basic principle of brickmaking has remained almost unchanged for thousands of years, modern factories have automated nearly every step of the process, making it possible to produce millions of high-quality bricks every day. Every brick begins with its most important raw material, clay. Depending on the region, the mineral composition of the clay can vary, directly affecting the brick's color, strength, and durability after firing. Once the clay is mined, it is transported to the factory and unloaded into raw material storage areas. From there, excavators continuously feed the clay onto conveyor belts to begin the processing stage. Before it can be shaped, the clay must first be crushed to break up large lumps and remove any remaining impurities. It then passes through a series of roller crushers that reduce it to a more uniform size, ensuring a stable forming process later on. Finally, the clay enters a mixer, where a carefully controlled amount of water is added to create the right level of plasticity. Even a difference of just a few % in moisture content can cause the clay to crack during drying or deform during forming, making the entire batch of bricks fail quality standards. Once the clay reaches the right level of plasticity, it is fed into a vacuum extruder, the heart of the entire forming process. Before being pushed through the machine, the clay passes through a vacuum chamber that removes most of the trapped air inside. If these air pockets are not removed, they can expand during firing at high temperatures, causing the bricks to crack or even break from the inside. Next, a large screw inside the extruder continuously compresses the clay and forces it through a shaping die, producing a long clay column with the exact cross-section of the finished brick. As soon as the clay leaves the die, an automatic cutting system slices it into individual green bricks with nearly identical dimensions. The cutting speed is perfectly synchronized with the extrusion speed, ensuring that every brick is the same length. Finally, robotic arms pick up the green bricks and carefully place them onto rail-mounted racks for the next drying stage. At this point, the bricks are still soft and can easily become damaged or deformed if they are handled improperly. After leaving the forming area, the green bricks still contain a large amount of moisture and are not strong enough to enter the kiln right away. They are stacked onto rail-mounted racks and slowly moved into a drying tunnel. Inside, powerful fans continuously circulate warm air around the bricks, allowing moisture to escape gradually from the inside out. This is one of the most critical stages in the entire production process. If the water evaporates too quickly, Internal pressure can build up and cause the bricks to crack or break before they are fired. On the other hand, if the bricks are not dried enough, the remaining moisture can also damage them when they reach high temperatures in the kiln. For this reason, the drying temperature, drying time, and airflow are all carefully controlled to ensure that every brick reaches a uniform moisture level. In many modern factories, waste heat from the kiln is reused for the drying process, improving energy efficiency while reducing fuel consumption. Once the bricks reach the required moisture level, they are sent directly into the tunnel kiln for firing. Once the bricks have reached the required moisture level, they are moved into a tunnel kiln where the quality of the final product is largely determined. Unlike traditional kilns where the bricks remain in place while the heat source moves, the brick-loaded carts slowly travel through different temperature zones inside a long tunnel. The temperature increases gradually from one zone to the next, allowing the bricks to adapt to the changing heat and minimizing the risk of thermal cracking. When the temperature reaches around 1800 to over 2000 °C, the minerals inside the clay begin to transform. The tiny particles bond tightly together through a process known as sintering, making the bricks much stronger and more durable without completely melting the material. This stage also determines the brick's final color. Even small changes in firing temperature, firing time, or the amount of oxygen inside the kiln can produce bricks ranging from red and orange to dark brown. By the time the bricks leave the tunnel kiln, they have gained the strength needed for the final cooling stage. After leaving the tunnel kiln, the bricks have reached their full strength, but they are still extremely hot. Instead of being cooled immediately, they pass through a cooling zone where the temperature is reduced gradually. This controlled cooling process helps prevent uneven shrinkage between the outer surface and the core, reducing the risk of small cracks that could weaken the finished bricks. Once the bricks have cooled to a safe temperature, they are moved to the quality inspection area. Here, workers or automated inspection systems check each batch for color, shape, dimensions, and surface quality. Any bricks that are cracked, warped, chipped, or improperly fired are removed from the production line. Depending on the factory's quality standards, sample bricks may also be tested for compressive strength and water absorption to ensure they meet construction requirements. Only bricks that pass all quality checks move on to the packaging stage. Bricks that pass the quality inspection move on to one of the most highly automated stages of the factory: packaging. Here, conveyor systems align the bricks in the correct orientation before robotic arms or specialized handling machines lift them in groups and stack them into neat, stable bundles on pallets. Each layer must be positioned accurately to keep the entire load balanced during lifting, storage, and transportation. Once the required number of bricks has been stacked, the pallet is secured with plastic straps, stretch wrap, or both, depending on the shipping requirements. This step not only keeps the bricks from shifting, but also reduces the risk of chipped edges during forklift handling. In modern factories, palletizing systems can operate almost continuously, reducing manual labor while keeping the production line running efficiently. After the pallets are securely packaged, they are ready to be stored in the warehouse or loaded directly onto trucks for delivery. After packaging is complete, the brick pallets are moved by forklifts to the storage area or loaded directly onto trucks if customer orders are ready for shipment. Inside the warehouse, the pallets are organized by production batch, making inventory management more efficient and allowing the factory to trace products if quality checks or customer issues arise later. When it is time for delivery, forklifts load the pallets onto trucks or shipping containers according to the transportation schedule. Each pallet typically weighs from several hundred kilograms to more than a ton, so nearly all loading and unloading is carried out using specialized equipment to ensure safety and minimize the risk of chipped or damaged bricks. From there, the bricks leave the factory and are delivered to distributors, construction sites, and eventually become part of the homes, schools, and other buildings that people use every day. Even with strict quality control throughout the production process, a small percentage of bricks will still fail to meet quality standards after firing. Instead of being thrown away, these defective bricks are usually collected and crushed into granular material. Because they have already been fired at extremely high temperatures, their internal structure has changed permanently, meaning they cannot be turned back into raw clay for making new bricks. Depending on the factory's production process, the crushed material may be mixed with fresh raw materials in carefully controlled amounts, or used as aggregate in other construction products. It is also widely used as road base material, backfill, or drainage layers in civil engineering projects. This approach reduces the amount of waste sent to landfills while making the best use of materials that have already gone through the energy-intensive firing process, improving both the efficiency and sustainability of modern brick manufacturing. Not all bricks are made the same way or designed for the same purpose. Fired clay bricks are the most common type and are widely used for walls and residential buildings because of their strength and long service life. Concrete bricks, often called unfired bricks, are made by compressing a mixture of cement, sand, and fine aggregates without using a kiln, significantly reducing energy consumption and carbon emissions. For applications that require extreme heat resistance, fire bricks are manufactured from special minerals that can withstand very high temperatures without losing their strength. There are also hollow bricks, solid bricks, and many other specialized designs, each engineered to meet different requirements for structural performance, weight, and thermal insulation. Few building materials are as common in our daily lives, and yet as easy to overlook, as bricks. What makes them remarkable is not only their strength, but also the fact that something as ordinary as clay can be transformed through engineering and manufacturing into a material capable of lasting for generations. The next time you see a brick wall or a building under construction, you may look at those ordinary bricks a little differently, knowing the remarkable journey behind each one. If you know an interesting fact about bricks or have a memorable experience involving them, feel free to share it in the comments below. And if you enjoyed this video, don't forget to like, subscribe, and turn on notifications so you won't miss future videos from Mido Explained.